Okay, so we will start. So this class will be maximum 1 hour, right? So I have some emotional work, so I'll finish at 7:30 to 7:45, right? 7:30 to 7:45 in between. So here today we are going to discuss Charpit's method, right? Charpit's method, and this method will be useful for finding the complete integral, right? For finding the complete integral. So first let us define what is meant by complete integral, right? So after defining complete integral, I will write formula for Charpit's method, and then we will do some 2 or 3 problems today, right? So first you will define what is meant by complete integral, what is meant by general integral, etc., right? So first let us define the following definitions, right? Yes. So complete integral, right? Complete integral. So complete integral, a solution which contains as many as arbitrary constant. A solution which contains as many as arbitrary constant as there are independent variable. Suppose the solution we are finding, in that solution, if the number of arbitrary constant is equal to number of independent variable, then we say that solution to be a complete solution, or it can be complete integral. Both are same, right? So complete integral or complete solution. So when we are finding, whatever the solution we are finding, if the solution has number of independent variable is equal to number of arbitrary constant, then that solution is called complete integral or complete solution, right? Yes. So for example, z is equal to ax plus by plus ab. So how many independent variable are here? So there are 2 independent variable, x and y. And how many arbitrary constant? There are 2 arbitrary constants. Therefore, this is a complete integral, right? This is a complete integral because ax, how many independent variable? If this solution is suppose this is a solution, there are two arbitrary constant a, b, two independent variable. If the number of arbitrary constant is same as number of independent variable, then the solution is called complete integral. This can be asked in 2 marks, right? Define complete integral. So remember this, right? Number of arbitrary constant is equal to number of independent variable, right? So suppose if you are giving some values to arbitrary constant, for example, a is equal to 2, b is equal to 3, then what will this equation becomes? This equation is equal to 2x plus 3y plus 6, right? So I am giving some arbitrary values to the arbitrary constant. Then this solution is called particular solution or particular integral. Particular integral or particular solution, right? So first we have defined complete integral, then we have defined particular integral. So when you want to write a particular integral, a solution obtained by giving a particular values to the arbitrary constant in a complete integral is called particular integral, right? So I'll read out, you write it down. So particular integral, a solution obtained by giving particular values to the arbitrary constant in a complete integral is called particular integral or particular solution, right? So if this is a particular integral, if the solution is obtained by giving some values to the arbitrary constant, then that solution is called the particular solution, right? So we have seen two definitions so far, complete integral and particular integral. So third definition is general integral, right? General integral. General integral. A solution of PDE which contains the maximum possible number of arbitrary functions is called general integral, right? Yes. So a solution of PDE, if the solution, if the number of arbitrary constant is equal to number of independent variable, then it is called complete solution, right? Now what does general integral means? A solution of PDE which contains the maximum possible number of arbitrary functions. The maximum possible number of arbitrary function is called general integral or general solution. For example, if you have seen, we have seen some solution of PDE by eliminating arbitrary constant, arbitrary function. So we have a solution like z is equal to f of x square minus y square. We will have some functions like this, right? So this is called a general solution for that partial differential equation, right? A solution of PDE which contains the maximum possible number of arbitrary functions is called, yes. So we have seen a lot of examples, right? So that is a function of x square minus y square. In Lagrange's, in solving the Lagrange's equation, we will have how many functions? We will have two functions, right? Z of x square minus y square plus comma something. So that solution is called, if that solution involves function, then it is called general integral, right? If the solution involves number of independent variable is equal to number of arbitrary constant, then that is called complete solution or complete integral. So far in Lagrange's linear equation, what we did is we have found the general integral, right? So the general integral is last we will write after finding two solutions, we will find the general integral is f of something comma something, that is called general integral. Now in Charpit's method we are going to find the complete integral, right? How to find the complete integral for the given PDE, that is what we are going to discuss in Charpit's method, right? Yes. So if the number of arbitrary constant is equal to number of independent variable in the solution, then it is called complete integral. If the solution contains maximum possible number of functions, then that is called the general integral, right? Yes. So we will move on to Charpit's method, right? So Charpit's method. Charpit's method, a general method of solving partial differential equation of order 1 but of any degree, right, but of any degree. So first what you have to do is you have to find the Charpit's auxiliary equation, right. So whatever the question may be, first you have to find the Charpit's auxiliary equation, right. So first I will write the auxiliary equation. Suppose if I have a question like something into P plus something into Q plus something, you can use Lagrange's method. Suppose if the question is not in that format, we will use Charpit's method, right. And also if they ask us to find complete integral, we have to use Charpit's method. So first what you have to do is, first we have to write the Charpit's auxiliary equation, right, Charpit's auxiliary equation. So let us given the partial differential equation of first order and non-linear in P and Q. Yes, and also in Lagrange's equation we can solve only linear. That is, in Lagrange's equation we will have something into P plus something into Q is equal to something. Here P and Q are linear. So if I have linear equation only, that is linear means P and Q are linear. That is we can solve only a quasi. In the beginning I have defined a lot of partial differential equation, like linear equation, linear quasi equation, non-linear equation. If P and Q are linear only, then we can use Lagrange's method, right. So what you can see, all problems we have solved, here P and Q will be linear. That is, we don't have P square or Q square or P cube or Q cube. But here in Charpit's method we can solve any, it can be linear or not be non-linear. If it is linear, go for Lagrange's method. If it is non-linear, go for Charpit's method, right. So I categorize this briefly, right. You use Charpit's when you use Lagrange's method. In exam, if they ask us to find complete integral, use Charpit's method. If the equation is non-linear, go for Charpit's method. If the equation is linear, go for Lagrange's method. If they ask us to find general integral, go for Lagrange's linear method. So suppose if I have first order equation, so let us given, so first we will write first Charpit's method, CHARPITS so Charpit's method, right. So let us given a PDE of order 1 and non-linear in P and Q. It's very important. And non-linear in P and Q. In non-linear P and Q. That is f of x, y, z, p, q is equal to 0. This is a linear equation, right? So z is a function of x and y, p is dou z by dou x, q is dou z by dou y. So we have to find the auxiliary equation. So I'll straight away write the formula. So the auxiliary equation is dp, it's a very big formula. So dp divided by fx plus p into fz, right. So fx means we have to differentiate this function with respect to x, with respect to z, and then you have to multiply p here. dq divided by fy plus qfx, right. fy plus qfx is equal to dz divided by minus pfp minus qfq is equal to dx divided by minus fp dy divided by minus fq is equal to df divided by 0. So this equation is called Charpit's auxiliary equation, right. So dp, dq, dz, dx, dy, df. So here we have to find first, given the question, we have to find this auxiliary equation. So and then I will write the working rule. Right, working rule. So the first step is transfer all terms of the given equation and denote the entire expression by f. So transfer all terms all terms of given equation to LHS. That is, what something is equal to something, you bring back all the term to LHS and put equal to 0, right? And denote the entire expression and denote the entire expression by f, right? So suppose if I have some question like something is equal to something, you bring all these terms to LHS and equate this term to be equal to 0 and you call this entire term to be equal to f. This is the first step, right? That is, our equation should be something equal to 0. So second step. So second step is write down Charpit's auxiliary equation, right? That is, we need to find all this and then we have to write Charpit's auxiliary equation. Charpit's auxiliary equation. Step 3. Step 3 is using the value of s. Say yes. Now after finding this, what you have to do is you need to solve any two, right? All are equal, right? So in Lagrange's, what you have to do, what you will do is we will solve this and this, you will find one solution, you will solve some other two, you will find another solution. Here what you have to do is select two proper fractions, so the resulting integral maybe comes out to be a simplest relation involving at least one p and q. So select, we will work out problem in easy for you. Select two proper fraction, so that resulting integral may be, come out to be simplest relation involving at least one p and q, right? So what they are saying is you need to compare any two and then you have to establish two relation involving p and q, right? Involving p and q. You can equate any two terms, right? You need to establish two relation that contains p and q, right? That even should contain at least one p and q. That is what they are saying. Select two TWO, right? Select two proper fraction, so that resulting integral may be come out to be simplest. That is, you have to select two fraction and then you have to integrate. So two fraction, you have to select two fraction and each solution has to contain at least one p or one q. Step 4. So here what you have to do is, here you have two equations containing p and q. Now you have to solve for p and q, right? Here you need to solve for p and q. After finding p and q, you need to find dz is equal to p dx plus q dy, right? So here we have two fractions or two equations containing p and q. You need to solve that equation and then you have to find the value of p and q, right? So here we have two equations in terms of p and q. You solve for p and q and substitute here. Substitute the value of p and substitute the value of q. So dz is equal to p dx plus q dy, which on integration gives the complete integral. That's it. So we work out problem and it is easy for you. Which on integration gives the complete integral. So first step is, what given the question, you have to transfer all the terms to this side so that E is equal to 0. You call that as f. After doing this, you find the Charpit's auxiliary equation, equate any two terms, any two fractions, so that our equation should be in terms of p and q, right? Actually it is not that you have to equate two proper fractions. So when work out problem I will explain both. And then our aim is to find p and q from here, right? And then you have to substitute p and q here, and integration of this gives z is equal to something. This is the complete integral. So we will work out problem. So Remember this working rule. So first problem, find the complete integral of, this question is asked in 1996 IAS, right? So first problem, find complete integral of z is equal to px plus qy plus p square plus q square, right? This is the question. Now they asked us to find complete integral. That means you have to solve that by Charpit's method. So what is our first step? You have to bring all the term to this side and have to equate that to equal to 0, right? So our f is, you bring all the term to this side. So our f is equal to z minus px minus qy minus p square minus q square. This is our f. After that, what you have to do is, you need to find the auxiliary equation. So for that, we need the value of fx, fy, fz and fp, fq, right? So we need 5 values. So first you will find fx, fy, fp and fq. So what will be my fx? We have to differentiate this with respect to x. So we will have minus p, right? So minus p and fy. So fy will be minus q, right? And fz will be 1. Differential with respect to z. Fz is 1. What will be my fp? So it will be minus x minus 2p, minus x minus 2p, and fq will be minus y minus 2q, right? So these are the terms that are required: fx, fy, fz and fp, fq. Yes. So this, now the auxiliary equation will be dp divided by fx. So fx is minus p plus p into fz. So fz is 1, and dq divided by fy plus qfx. So fy is minus q plus q into fx. So fx is minus p, right? Fy, sorry, fz, sorry, change this to fz, right? Fx plus p fz, fy plus q fz, please change to fz, right? So it will be fz is 1 minus dz divided by minus p into fp. So what will be my fp? Fp is minus x minus 2p minus q into fq. So fq is minus y minus 2q. So this question asked in 1996, right? And this is equal to dx divided by minus fp. So minus fp will be minus of x minus 2p, minus of minus x minus 2p is equal to dy divided by minus fq. So minus of y minus 2q, that is equal to df by 0, right? So you have found fx, fy, fz, fp, fq separately, and then you have substituted here. Now our aim is to find p and q, right? Now you can clearly see this will be equal to 0, this will be equal to 0, this whatever may be. If the denominator is equal to 0, then what we can conclude? This is a solution, right? In Lagrange's method, what we will do? We will find some multiplier, and if that multiplier is equal to 0, then integration of numerator is solution. So that means whatever this term may be, write this right as it is. Now since dp by 0, we have integral of dp is one solution, that is p is equal to some constant. So p is equal to a, right? So here you will denote constant by ab, right? You will not use c1, c2, you will denote constants by ab. So p is equal to a. So again dq by 0. So this implies integral of dq is one solution. That means q is equal to b. Right? So we have found p and q very easily. What is our aim? Our aim is to find p and q from by taking any two fractions. So from this fraction I have found p, and from this fraction we have found q. Right? So what is our complete integral? Suppose if it is not 0, we will integrate and then we will find two fractions and then we solve for p and q. But here came out to be very easily, right? So we have dp by 0, dq by 0. So therefore, what will be our complete integral? Complete integral is dz is equal to p dx plus q dy. We have to integrate this, right? Integration of the complete integral. So z is equal to p. What is our p? P is a, right? P is a. Yes. What is our p? P is a. Yes. So this will be ax plus by. Z is equal to ax plus by. This is our complete integral, right? That's it. So I move on to next problem, right? So this question asks 15 marks, right? So if you know this formula, you can do this in just 2 or 3 minutes. So we move on to second problem. So the second problem is q is equal to 3p square, right? Find the complete integral. Find complete integral. Q is equal to 3p square. So what will be my f? So our f of what will be my f? We have to bring all the term to this side. That means q minus 3p square. So this is our f. So we will find fx, fy, fz, and then fp, fq, right? So what is our fx? It is 0, right? Because there is it is not clear. Is it okay now? Please explain how it became a and b. That is just the integration constant. A and b are just integration constant. Is it clear now? Screen is clear. Okay. So our question is f is equal to q minus 3p square So our f is q minus 3p square, right? is q minus 3p square. So this equation does not involve x, right? So fx will be 0, fy will also be 0, and fz is also equal to 0, and fp. So fp will be differentiating this with respect to p. So we will have minus 6p, right? Minus 6p, and fq will be 1. Fq will be 1. So again substituting this term here. So we will have dp divided by fx. So fx is 0, p into fz is also 0. So dq divided by fy is 0, this also equal to 0. Now this whatever may be, right, this whatever may be, so minus p into fp, so minus 6p minus q into fq is 1, and dx divided by minus fp, it will be 6p, and this will be dy divided by minus fq. So minus 1 is equal to df by 0. Now again you can see from here we have dp by 0. That means integration of dp is constant, right? That means integration of p dp is solution. That means p is equal to a. So this a is arbitrary constant, right? This integration constant. Integration of this will be p plus a. And again dq divided by 0. So this implies integral of dq is one solution. That means q is equal to constant b, right? So when you integrate this, you will have q plus c. That will be, I'm taking that constant to be b, right? That's it. So what is our complete integral? So complete integral is z is equal to integral p dx plus integral q dy. So what is our p here? Again it is equal to a. Yes. Now from here what you can do is, we can also take q to be equal to b, or what I can do is substituting the value of p in equation number 1, right? So this is equal to 0. This is our equation number 1. Or else you can also find q by r. So you can also find q by, so q minus 3p square is equal to 0. So our q will be 3p square, and since p is equal to a, q is equal to 3a square. You can also find q in terms of a, right? So we can also write this to be equal to integral a dx plus integral q dy. Yes. We have to, yes, I ought to say one thing, right? So u is equal to a. So in last problem what we did, yes. Now we can either substitute q is equal to 3a square or a, right? So if I do this, this will be integral, if I substitute q is equal to 3a square, so 3a square dy. So this will be ax plus 3a square y plus some integration constant b, right? Or else you can also substitute q to be equal to b, right? So now we move on to third problem. third problem is so find the complete integral of find complete integral p square minus y square cube is equal to y square minus x square. This is very important problem. This is also very important problem. So first step is to write everything. You have to bring every term to here and then you have to equal to 0. So we have p square minus y square cube minus y square plus x square is equal to 0. This is our f. Now we have to write the auxiliary equation. So before that, what we will do, we will find fx, fy, fz, fp and fq. Right? We have to find this. So what will be my fx? Differentiating this with respect to x. So we will have 2x. Fy. So differentiate this with respect to y. So here you will have minus 2y cube minus 2y cube minus 2y. So fz will be 0. Fz will be 0 and fz is 0. Fp. So fp is 2p. That's it, right? 2p and fq. So fq here we have 1. So we have minus y square. So we have found fx, fy, fz, fp and fq. Now we have to write the Charpit's equation. So Charpit's equation is dp divided by fx plus p into fz is equal to dq divided by fy plus q into fz is equal to dz divided by minus p fq plus minus q fq and this will be dx divided by minus fp dy divided by minus fq. So by here you will have dp divided by, so fx is 2x plus p into fz. So fz is 0, right? Fz is 0. Now here we will have dq divided by fy. So fy is minus 2y cube minus 2y minus 2y cube minus 2y, and since fz is 0, this term entire term will be 0, and dz divided by minus p into fp. So fp is 2p minus q into fq. So fq is minus y square. This is equal to dx divided by minus fp. So we will have minus 2p and this is equal to dy divided by minus fq. So we will have y square. So this is our Charpit's auxiliary equation. Now what we can do is we can find, so in the last problem what I said is, if you find p, you can substitute the value of p in this equation to find the value of q. That's what we did in the previous sum, right? So we have p is equal to a and then I substitute in the question to get q is equal to 3a square. So similar way, it is enough for us to only find p from here and then you substitute the value of p in this equation to get the value of q. So first we have to find p. So taking the first and the fourth fraction. So here we have dp divided by 2x. So here we have, so you can see this is not 0. So the previous problem we have 0, so that the problem get easier. So here it is non-zero. So if you see this, here we have dx divided by minus 2p. Now I am going to equate this term and this term, right? So if I equate this term and this term, we will have dp by 2x is equal to dx by minus 2p. So I can write this as 2 will get cancelled. So it will be minus p dp is equal to x dx. So if I integrate this, we will have minus p square by 2 is equal to x square by 2 plus some constant a, right? Plus some constant a. So we have, So if I bring this to this side, so I can write a to be equal to p square plus x square, right? So since a is arbitrary constant, so I can neglect 2 and I can also neglect minus of p square plus x square, right? So our a will be a will be p square plus x square. So just for the simplicity, what I'm going to do is I'm going to write this as a square, so that the problem will be easier, because a is that's a constant, right? So I'm writing a square to be equal to p square plus x square. Now mark this equation as 2, right? So this is our equation number 1, right? So p square minus y square cube minus y square plus x square. So we will solve this equation and this equation now, right? Yes. So what is our first equation now? So we need to solve this equation and this equation to find the value of p and q, right? So our first equation is p square minus y square cube minus y square plus x square equal to 0, and this equation is a square is equal to p square plus x square. Now we need to solve this two equation to find the value of p and q, right? So how can we solve these two equations? So p square minus y square cube. So if I replace p square plus x square to be a square, so this equation will be a square minus y square cube minus y square, right? So p square, we need to solve for p and q. Wait a minute. So we need to solve this equation for p and q, right? Now, so we will write this equation in terms of p and q, because we need to solve this equation for p and q, right? So what I can do is, so I'll write p square minus y square cube. So we will solve for p and q only, right? So we will keep this here and then we'll go back, we'll change this term to this side. So here we will have p square and we don't have q here, so this will be x square minus a square, right? Now if I subtract this, so this will be minus, this will be minus, this will be minus. So these two terms will get cancelled. So we have minus y square cube is equal to, and if I subtract this term will get vanished. So we have y square minus a square. So this implies q is equal to y square minus a square divided by minus y square, right? So I need to solve for p and q, that's it. And then I have to substitute in dz is equal to p dx plus q dy. So I can write this as, so y square minus a square by y square. So I can write this as y square by minus y square. So if I minus a square divided by y square, this will be minus 1 minus a square y square, right? Or else I can also write this as minus plus, right? I can also write this as a square y power minus 2 minus 1. This is our q, right? So q is equal to a square y power minus 2 minus 1. Now we know that we need to find value of p now, right? So I have found q. Now I need to find the value of p now. This we can do this very easily, right? So q is equal to a square. Yes, we got the right answer. Q is equal to a square y power minus 2 minus 1. Where minus 2x square? Okay. A square minus x square, right? So p square is equal to a square minus x square. So a square minus x square. So we are finding p square only, right? So p square is equal to a square minus x square. Now this will get cancelled, right? So this and this will get cancelled. So minus x square plus x square. So we have y square minus a square. So this is our. Now we need to find the value of p. Fourth problem, right? Now we already have that p square plus x square is equal to a square, right? So from this we can find p square is equal to a square minus x square. So p is equal to a square minus x square whole power 1 by 2. So we have found p and q. Now what will be a complete integral? Dz is equal to p dx plus q dy, right? Dz is equal to p dx plus q dy. Now we just have to substitute here and then we have to integrate. So this will be, what will be my p? So a square minus x square whole power 1 by 2 dx plus, and our q is a square y power minus 2 minus 1 dy, right? Now we just integrate this, right? Integrate this with respect to x. So this will be dz is equal to integral square root of, z is equal to integral square root of a square minus x square dx plus integral, right? Integral, and this I can write this term to be a square y power minus 2 dy minus integral dy, right? Now use a square root of a square minus x square formula, right? This x by 2 square root of sin x by 2 square root of a square minus x square plus sin x by a, that formula. So we apply that formula here, and this will be a square will be constant, so I can take I can integrate y power minus 2 straight away, and that will be y, right? So if you use this formula, this will be x by 2 square root of a square minus x square. So it's a basic formula. So we have z is equal to, so I'll straight away write the formula, x by 2 square root of a square minus x square plus a square by 2 sin inverse x by a, right? This is the formula for this entire term plus a square. Now integrate y power minus 2. So integration of y power minus 2 is y power minus 2 plus 1 divided by minus 2 plus 1. So we have y power minus 1 by minus 1, that is minus 1 by y. That is minus 1 by y, and this will be minus y plus some arbitrary constant. So this is our complete integral. Right? Yes. So we have solved 3 problems now, right? the first problem, the first two problem, we have a dp by 0, dq by 0, so that the problem will get very easy for us. So if the denominator is not equal to 0, you have to find one solution. Either it can be p is equal to or q is equal to, and then you have to substitute in the given equation, and then you have to solve for p and q, and then you have to substitute here, right? So we have to do lots of problems. There are also aliter for finding a p and q, right? So that I will discuss tomorrow, right? So I'll tell you the aliter for finding p and q very easily, right? So I have some very urgent work, so I'll see tomorrow, right? So tomorrow there is a slight change in timing, so I'll text as soon as possible. So far today what we have seen is, we have seen I have introduced the auxiliary equation for Charpit's method, and then we have solved 3 problems, right? So tomorrow I'll extend time and then I'll compensate for maybe half an hour, right? So we'll see tomorrow, right? Thank you.